Hello and welcome to the session. In this session, we discuss about K nearest neighbor algorithm. Some important points related to KNN we'll be discussing here. We'll discuss what is data normalization or standardization in KNN. We'll see what is the impact of K value in KNN, or in turn we'll decide how we can choose a value of K. We will see an extension of KNN called as weighted KNNs. See, we have learned about KNN in the previous two videos. Please go through that video before you see this video. See, when we are talking about KNN, basically it's all about computing the distance from the test instance to the training instances, right? So when you're calculating the values, it's possible that, for example, when you see this diagram, this is a test instance. I'm calculating the distance from this data point, from this training instance to these data point. If I calculate the distance from here to this, you can see that, suppose the distance from here to here in millimeters, suppose the distance from here to here is in meters. So that means it's not really a comparison, right? So when you're doing such calculations, it's important that they are in the same range, right? Suppose they are not in the same range, then you have to adopt normalization or standardization. So when the data have different ranges or wider range of possible values, or you have features within different ranges, then the solution is perform data normalization or standardization. Now, why do I have to do this? To eliminate the influence of one feature over another. So suppose you don't do data normalization, it's not really a correct calculation, as well as the data point which is having a lower range will get lesser importance as compared to the data point which is at a larger range. So for that reason, it's very important that you do data normalization or standardization to ensure that the ranges or the possible values are in the same range. There's one more very important point is when you're working on KNN algorithm, the first question you get is how do you choose a value of K? So your KNN classification's performance basically depends upon three factors. One is the selection of K, the second one is the distance metric and decision rule. See, selection of K is how do you select the value of K? See, suppose K is basically what? The number of nearest neighbors. If I choose a value which is very small, then what happens is you will be selecting very few nearest neighbors to your test instance, and therefore your problem is not very generalized. You will be making it very specific to a particular training data. So that means it will result in overfitting issues, or you will have a very less stable algorithm. Now suppose I go for a very big value of K, then what happens is you will be having lot of neighbors. You are actually selecting lot of neighbors for your test instance. Since you are having more nearest neighbors in your algorithm, many irrelevant point also will be classified, will be considered for classifications. So that can also result in wrong classification. The second one is the choice of distance metric. So choice of distance metric in the sense, just now we saw that if a point is at different distances, suppose you have a training data set which is very close in the range of millimeters, another training data set which is in the range of meters. So if you are giving equal importance to both, then it is affecting the algorithm, because you are giving more importance. You may in turn give more importance to the training data set which has a larger range because it has a high numerical value. So it's very important that how you choose your distance metrics. It should be independent of the value. The distance metric should be independent of the value of your training data set. So a value is having a bigger number. The training data set has a bigger number doesn't mean that it has to be given importance. So that's the meaning. The third one is, and also very important, is KNN is very much suitable only for data which is in low dimensions. If you are working on high dimensional space, then going for KNN will not be very good, because you will not be able to choose nearest neighbors in a very high dimensional space. Having nearest neighbors would be not be a correct solution. Now coming to weighted KNN. So as a solution to the existing KNN, you have an extension called as weighted KNN, where you actually give weights to the distance. In the last problem, in the last session, we saw that we calculated the Euclidean distance from the test data point to the training data instances. But we did not make any difference, right? We just have a common formula where we just calculate the square root of the distance, squares of the distance. But the problem here is when we go for the KNN, normal KNN, we do not give weights. We do not give any importance to particular point. So as a solution, we can go for weighted KNN. Weighted KNN, principal idea is we give higher weights. We give higher weights to the test instances which are closer. So when you give higher weights, right, they will impact the decision, right? You give higher weights to certain neighbors, thereby giving it more importance for classification. So K nearest closest neighbors are assigned to test instance with higher weights in decision as compared to neighbors that are farther away from test instances. So points which are far from the test instance will have lesser weights, and points which are closer to the test instance will have higher weights. Therefore what happens is you give more importance, so that thereby you are able to select nearest neighbors in a much effective way. Now the thing is, how do you choose a value of the weights? So value of weights is inversely proportional to the distance. So if the distance between the test point to a training point is less, the weight is more, and therefore it is given more importance. So if suppose I don't give weights, then it's as simple as the simple KNN. All of them we are getting all the training distances will be getting equal weights. If you are giving weights, then ensure that you give you give more weights for the data points which are much nearer to your test point. So now let's see the algorithm of the weighted KNN. So the inputs to the weighted KNN are, you have a training data set T, distance metric D, weighing function W, test instance T. So if you see the inputs as compared to the just a normal KNN, the weighing function is the extra one which we are seeing here. Output. So output will remain the same. You will be predicting a class or a category. So let's suppose I have a test instance T. Right, suppose I have a test instance T. This step remains the same as the previous KNN algorithm, where we are just calculating the Euclidean distance between the training data point and the test data point. Then again the step 2 also remains the same. We have seen in the previous problem, we saw the distances in the ascending order, and we select the first k nearest training data instances to the test instance. This is what we did in the previous problem. We took k as 3, and therefore we selected first 3 data points which were closer to the test instance. Now this is the difference. The third point is what is different. Now we predict the class of the test instance by weighted weighing technique. So now we are using a weighing function called as W of I for the k selected nearest instance. So now we will be applying the weighing function W for the k selected nearest instance. So suppose I have selected 3 nearest training data instances. For that, apply the weighing function. So how do you compute the weight? So we compute the weight as an inverse of the distance, and then we find the sum of the inverses. After that, we compute the weight by dividing each inverse distance by the sum. Then we add up the weights of the same class, and based upon that we predict the class by choosing the class with the maximum vote. Again we have the majority voting system like we had in the simple KNN. So in the next session we will see the problem on this. So once you work out the problem, writing this algorithm will be more simpler. So come back after doing the problem, see this algorithm. It will be easier to write the algorithm once you make sense by applying it in a problem. So let's see in the next session where we'll be working out on the problem concerned to weighted KNN. So please subscribe to the channel. Please share this video with your friends. Thank you so much.